Okay. So the first theorem to prove congruency is called side, side, side. The second one is side angle side. Do you remember that one? Okay. And the third one is angle side angle. Okay. And the last one, the fourth one is called angle angle side. Angle angle side. Well, because we're talking about triangles, so therefore angle angle side, it's pretty much the same as angle side angle. Because if we say we got those two triangles, if this side is congruent and this angle is congruent to this angle and this angle is congruent to this angle, well, because add together we'll get 180. So therefore this angle automatically congruent to this angle. So therefore actually you got is angle. This is a side angle. So it's actually is this one. So this is a kind of uh, variant on this one. Good. Okay, very good. So now we get into today's lesson is talking about parallelogram. We actually learned about that earlier on. Uh, Now we're going to dive deeper into it. So first of all, we're talking about definition. Now, definition is something kind of like tell us what is something. So, so definition tells us what actually is a parallelogram. How do we know quadrilateral is a parallelogram? So this is kind of about what. And later on, we're going to learn, right after that, we're going to learn about properties. Properties will tell us the behavior of something, okay? Like, for example, you can say a car has four wheels and a body and some, engines. So that's kind of what. And the how part of it, the behavior part of it is that you can some cars can go like 0 to 60 miles per hour in 10 seconds, and some can go that in 4 seconds. So those are the behaviors. So same thing when we study actually when we study anything, not just math. Anything we started, we first of all we're going to make sure we understand the definition because definition tell us what is the things we are studying. So in this case, we have to define a parallelogram. So the definition for that is this. First of all, it has to be a quadrilateral, which has four sides. Then second of all is that both pairs of corresponding sides parallel. So that means this are corresponding sides, and this is parallel to this. So that's the one pair. Then the other pair, this side has to parallel to that. We got this parallel to that. So as long as we have one pair corresponding side parallel and the second pair also uh, parallel, then this is a parallelogram. Good. Okay, now we're going to talk about properties. Property, it basically says if this is a parallelogram, what, how does it behave? Anything, um, anything special about it? Okay, it's kind of talking about the behavior. So we have defined it. Then we're going to looking at the properties, and you can see that this pretty much this is the common uh, methodology we use to study something. Doesn't matter what, math, physics, chemistry, or history, we always make sure we understand its definition. Then we're looking at its properties. So the first one, the properties mostly, that's where the theorems tells us. Okay, so the first theorem we have is corresponding sides of parallelogram are congruent. That basically says if it's a parallelogram, then this side is congruent to that side. That means AB, we write like that, line segment is congruent to CD. Okay, and so we write like this for congruency. And also, not just this pair, they are we call about corresponding sides of a parallelogram congruent. So also about this side. So this side also has to be congruent to that. So we got AD also congruent to uh, BC. So that's a property of parallelogram. As long as a parallelogram, then the corresponding sides are congruent. So this side congruent to that side. Also, this side is congruent to this side. Okay, we good on this one? So now we're going to actually prove it. Why is that? Because any theorems, we have to prove it. To prove it, we're going to use the triangle congruency. And you can see that triangle congruency is used a lot for proving in geometry. So what do we know? Based on the definition, if this is a parallelogram, so we know this side is parallel to this side, and this side is parallel to this side. Now we're going to draw a line, connect B and D, like this dot line. So now we can see because AD is parallel to BC. And according to the property of parallel lines we learned early on, the alternate interior angles are congruent. So those two angles are congruent because this is congruent to that, parallel to that. And also we know this side, I'm going to choose different color. This side are parallel to this side. So therefore, the this angle and this angle are congruent. Now, as you can see, we have two angles are congruent. And between these two angles, we have the side, which is common. So therefore, we have angle, side angle. Now, which means that the triangle on the left, which is triangle ABD, so triangle on this side, this triangle is congruent to the other side. We draw this triangle. And because, so this is congruent to triangle CDB. And because the two triangles are congruent, remember we have this called CPCTC. That means corresponding parts of a corresponding or congruent triangle are congruent. So that means AB has to be congruent to DC because they are the corresponding part of a triangle, congruent triangle. And also AD is congruent to BC. So that's exactly what this theorem is about. You can see that we actually can prove it based on triangle congruency to show that this theorem actually is true. Good? Very good. So now we get on to second theorem is said corresponding angles of a parallelogram are congruent. That means this angle is congruent to this angle, and this angle is congruent to that angle. So just basically drawing, you can see that actually that makes sense. Well, to prove that, we actually going to use the properties of quadrilateral and parallel lines. Okay, let's call this the blue one X. So we got X, X. The white angle, the red angle is Y. What do we know? We know when we add all together, we got 2X plus 2Y. That should be equal to 360 because that's, this is two triangles. Each triangle is 180. So we have that. Now we divide by 2, X plus Y is 180. Okay, now there's something about parallel lines. Parallel line says that the consecutive, this angle and this angle, if they are 180, then this line and this line will be parallel. Well, now we can see that X, here's the X, here's the Y. They add together 180, so this line has to be parallel to that line. And also here, Y add X, 180, so this line is parallel to that line, which is what defines a parallelogram. So therefore, the second theorem also is true. Good. All right. Let's look at our third one. Third one says the diagonals of parallelogram bisect each other. Okay. Well, that means we know the BD is already a diagonal, and we can draw the other diagonal. And you can see that actually this side, let's call this one is O. So this side, AO, actually is equal to CO because they are this BD bisect AC. Bisect means cut them to two equal parts. And also this diagonal bisect this diagonal. So therefore BO is equal to DO. So that means this side is congruent to this side, and this is congruent to this. Good? Okay, so now we have to prove it. That's the case. Well, how do we do that? And we're starting with that. We know it's a parallelogram. Okay, a parallelogram. We know that because this line and this line are parallel, so therefore this angle and this angle are congruent. And also, we know this angle. Oh, sorry, wrong side. And this blue one, this angle and this angle actually, so they are alternate interior angles. And then we also know this side is congruent to this side. So therefore, we got two angles. We got angle now. We need the side. Well, the side, based on this theorem, a parallelogram, the corresponding sides of parallelogram are congruent. So that means this side, AD, is equal to BC. So now we have angle, this angle, and side, this side, and this angle. So angle, side angle, angle, side angle. So therefore, we got two congruent triangles. One is the one on the top here, which is triangle AOD. That is congruent to the bottom triangle. Right here. That is COB triangle. Okay, now we have that. Then based on CPCTC, corresponding parts of a congruent triangle are congruent. So therefore, we know this side, use different color. we know this side is going to be congruent to this side. Well, that means they are the same. So therefore, this and that are the congruent. And also, this side is congruent to this side. So that means this is congruent to that. Well, now you can see this point is right in the middle. So that means this line bisect this diagonal, and this diagonal bisect this diagonal. Good? All right, very good. So now we're going to do some practice. Okay, and we got three theorems, okay? Theorem one is corresponding sides of the parallelogram are congruent. Theorem two, corresponding angles of a parallelogram are congruent. And theorem three is the diagonals of a parallelogram bisect each other. So we're going to use that to do this exercise. So exercise, oh, I'm going to actually rewrite it, okay? Down here so you can see it. Theorem one, corresponding sides are congruent. I can use TH. Oh, actually do that. Use, I can write that over here. Okay. The first theorem, that is corresponding sides are congruent. Congruent. Congruent, you can use this symbol. And theorem two is corresponding angles are congruent. So first is a side, and this is angle. Angles are congruent. And theorem three is the diagonals bisect each other. Bisects each other. Okay, so we have that. All right. So first one, we got A, B, C, D. A, B, C, D. Now, first one, we say AD is this one, parallel to BC. So what's this based on? So we're trying to, either we say it's which theorem or the definition of the parallelogram. Good? Yeah, so what's the answer for one? Hello, Mia? Yeah, you can either say it or you can just type it in the chat. We need to have the reason here. And this is our statement. And we need to give a reason. So the first one is AD parallel to BC, based on what? Well, this actually is based on the definition. Good. Remember the definition about parallelogram is that this side is parallel to that side, and this side is parallel to that side. Okay, now we're looking at the second one. Angle ADX, AD, okay, we have, forgot this one. This should be X here. We got X here. ADX, ADX, ADX will be this angle. Angle ADX equal to CBX, CBX. So we're talking about these two angles, they are congruent. So what's this based on? Yeah, it's alternate interior angles. Very good. And that actually is based on the definition because it defined it as we know that parallel. Okay. Number three, measure. Number three, measure of ABC, ABC, this angle is the same as CDA. So those two angles are congruent. So which theorem that based on? Yeah, so we got theorem one, theorem two, and theorem three. So which one do you think that makes sense? Yes, it's theorem two. Very good. And number four, AD is congruent to BC. So that means AD here, that is congruent to BC. So which theorem is based on? Yep, very good. Theorem one. And five, so we're going to say this line and this line. This is our x. So AX is here. AX is half of AC. Right. That because the diagonals bisect each other. So theorem three. How about number six? dx equal to bx. dx from here to here. bx is from here to here. So those two are congruent. Very good. Yeah, it is theorem three based on that. Okay, so now we're going to do some calculation based on the property. Number 7, we're going to find the value of a, b, x, and y, okay? We're going to do the number 7. Number 7, oh, oh. Number 7, we know this is 10, this is 8. We want to find a and b, and this is 62 degrees. We want to find out x and y, okay? So based on the properties of parallelogram, we should be able to figure out what is a, b, and x and y. Yeah, you can just put on the chat. Very good. Good job. Okay, let's do number 8. Well, A is good, B is good, but the X here, you can see this is X. X is corresponding to that. So actually, X is equal to 80. Yeah. Now, how about Y? Well, we know this part, the whole thing here, add this should give us 180 because they are parallel. So therefore, 30 plus Y plus X should be 180. But X we just found out is 8. So therefore, we got 110 plus Y equal to 180. Then Y is 70. So 30 plus 70 is 100, 100 plus 80, 180. So that works out. Good? Okay, very good. Let's do number 9, okay? Well, on this one, first of all, we know A is here, this side, and corresponding one is 5. So A is 5. Then we look at the B. B is on the top, which is here, and on corresponding is 3. So B is equal to 3. Now we just need to figure out what is our X and our Y. Now, X actually is here. X is corresponding to this angle. So that's how it's corresponding. So X is 120. Now, the Y, just like we did X early on, we know that this whole thing here at 120 should be 180. So this part, side, which is Y plus 38, that should equal to 60. So 60 plus 120 is 180. So Y is 60 minus 38. That gave us 22. So that's how we got there. Good. Perfect. Now let's do number 10. Okay, well, first of all, we see that this part is, it told us this whole part, this is 9. So therefore, we know the diagonals bisecting each other. So we know from here to here is 9, and this is A. So A equal to 9. And down here, B is here, and on this side is 11. So B is 11. Yeah. So are we good here so far? Okay, very good. So now we just need to figure out, well, we know this is 33, and X here, so basically is the alternate interior angles. So therefore, X is equal to 33. And now we're trying to figure out Y. Well, we know Y is congruent to here. Okay. And but we know the whole thing here, Y0 plus, so Y plus 50, this whole thing here is actually adding this, give us 180. Well, what is this side? So we know those whole thing here is Y plus 50, and adding this side, this should be 180. Well, this side we have 70 plus 33, that equals 180. So we got Y plus, this give us 120 plus 33, 180. Then we have Y plus 153 equal to 180. So minus 153 on both sides, then Y will be 727. So that's how we got here. Yeah. So we good on this one? Okay, perfect. Well, we have two more to go, okay? We got 11 and 12. So, well, let's see how we do this one. Well, first of all, B actually is pretty straightforward. B is here. And the corresponding side is this side, which is 8. So therefore, B is equal to 8. So we got that. Now, where's A? A is from here to here. And but we know this side, the other side is 8. So therefore, based on uh, theorem 3, that the diagonals bisect each other. So therefore, A has to equal to 8 too. Okay, are we good here so far? Wonderful. So now we just need to looking at for what is X and what is Y. Well, we know this angle, 26, and the whole thing here is 56 plus 26, which is uh, 82. So therefore, this whole thing here will be 180 minus 82. So that would be 8 and borrow. So be 98. So we know it's 98 here. Okay. So now let's see what we can have. Well, we got this angle is the same as this angle. Okay. Because that's vertical angles. So this side is also x. And we know why. Uh, this gives us y here. Good. So now we have 26 here. That means this side also 26. And of course, this side will be 56. Okay. And so now we can see x plus y will be um, x plus y plus this angle plus 56 is 180. Yeah. So we got one equation set up. And we also know that this one here, y plus this angle, let's call that z, that is equal to 98. And we know this side. Yeah, this side will be equal to this side. So that's also y. So let me see. This is x. Um, Let me make sure that that's clear. Okay. Um, so we know this side is 26 and this side is 58, 56. And the whole thing here is 98. And so we got xy plus 56 is first one, 180. Let's see if we can find the other um, that will give us. Okay, so we know this one is 98 also. Um, Let me think. I think we're missing something. Let me check. Okay. Uh, so let's call this one Z. Yeah. So we got Y plus Z is called 98. And also Y plus Z, 98. X plus Y plus that, 180. Huh. Well, let me think about this one, okay? So, but anyway, we got A and B. So each 8 and 8. So we got last one, 12, okay? Very good. A 10, B is 4, X is 90. Well, Y, very good, but Y is not 90, okay? Uh, so this is 45, this is 90. So this side has to be 45. So therefore, Y is 45 degrees. But the rest, you got that correct. Good? Very good. So that's what we have for today. I'll see you next week, okay? Bye.
Bye.